Ratio and proportion. In our day-to-day life, we often come across situations where we need to compare quantities. Say, in our class, we may be checking the cutoff required to reach a particular grade. For this, we have to compare the grade cutoff and the marks we are supposed to obtain. Or we may be comparing heights of two students. But for comparison, we know that we use greater than, lesser than, or equal to signs. While comparing two students, we may say one is taller than another. But if we want to be more precise, like taller by how many units, in such a situation, we need to know the magnitudes of these two quantities. In this case, we have to know the heights of both the students. So this particular measurement is called as magnitude. And while these magnitudes are closer to each other, we will take the difference of both the magnitudes and compare. Now, this particular type of comparison is called as comparison by difference. We are taking difference of magnitudes. We may say student A is 12 inches taller than student B. But when the magnitudes we want to compare are not closer to each other, consider the height of an elephant to a height of a dog. The values won't be closer. In such a case, we divide these magnitudes and do the comparison. We may say elephant is 4 times taller than the dog. There are two types of comparison. One tells how much more or less. For this, we need to find the difference of magnitudes. And in the second way of comparison, how many times something is more or less than the second object in comparison. The case wherein we have to do the division. This way of dividing the magnitudes of two quantities of the same kind is called as ratio. Two quantities means we need to have two things. In the previous case, one is the height of elephant and the second one is height of dog. Same kind means we are comparing height of first quantity with height of second quantity. Then only it is called as ratio. Say if we want to compare weight of elephant against height of dog, that is not a ratio. That is not a proper comparison. They are not of same kind. One is weight and the other one is height. So we can't compare like this. That particular comparison is not called as a ratio. While writing a ratio, we will write like height of elephant is to height of dog is equal to 4:1. This particular column that we are seeing here is called as is to. We have to read this as is to. When we read this as a statement, we'll say height of elephant is 4 times the height of dog. So the ratio tells how many times a particular quantity is to the other quantity. We'll see another example. Now consider the thickness of a pencil against the height of a pencil. Say thickness of pencil is 8 mm and height of the pencil is 16 centimeters. Now how to write a ratio? Let us write like height of pencil is to thickness of pencil equal to, substitute the values, 16:8. These things we can divide them with 8 on both the sides and can be written as 2:1. Now try to read this as a statement the way we have done in the previous step. Here it is height of pencil is, then we have to read this, 2 times the thickness of pencil. Is this correct? No. Why is this not correct? See here, the thickness we have taken is in millimeters. We have taken 8 millimeters thickness of a pencil against the height of pencil which is given in centimeters. So they are not in same units. So this particular comparison is not valid. To write a ratio, first we have to convert them into same units. We know that 1 centimeter is equal to 10 millimeters. Using that, we can write 16 centimeters would be equal to 160 millimeters. Now, both the thickness and height are in same units. We'll compare this now. So, 160 is to 8. Now, again, if we divide these things with 8, we'll get 20:1. Now, when we read this, we'll first say height of pencil is 20 times the thickness of pencil, which makes some sense. So in this way, while doing the comparison, we need two quantities and they have to be of same kind. Even the units have to be same. Now, this particular ratio can be written as A is to B or A divided by B or A upon B. We know this A upon B as we have seen them in fractions where B is not equal to 0. So, can a ratio be written as a fraction? Let us check this. Consider this fraction. This is 1 upon 2 and also a ratio 1 is to 2. As we have seen, that ratio can be written as A is to B or A divided by B or A upon B. We are considering these last two things. When we say a fraction, it represents how many parts are to be considered from a whole thing. So, a sandwich. Here we have two pieces of sandwich and we need to consider one out of the two pieces when we say 1 upon 2. So, we can tell that Ram is eating half a sandwich. Now again, what is this 1 is to 2? Here, the 1 is to 2 means we are telling that one sandwich is to be divided or distributed among two people. How can we do this? We again have to cut this into two pieces and give one to each. In this case also, each person will get half sandwich. So both are same. So a particular ratio can be written as a fraction also. Now let us understand the terms in ratio. We are writing ratio as A is to B. A is the first term and B is the last term. And the middle column, read it as is to. This first term is called as antecedent and the second term B is called as consequent. Both the antecedent and consequent can be multiplied or divided by a non-zero number, same non-zero number. When we do this multiplication or division, we will get the equivalent ratio. Consider an example, say 35 is to 15. This is a ratio, 35 is antecedent and 15 is consequent. Now we will divide both the antecedent and consequence with 5. After dividing these with 5, we will get 7 is to 3. So 35 is to 15 can also be written as 7 is to 3. Or in another case, we will try to do the multiplication. Here we will multiply both antecedent and consequent with 2. In this case, they will get modified as 70 is to 30. So even this would be equal here. All these ratios are now equivalent. They represent one and the same. A simplest form of ratio. A is to B is said to be in its simplest form when its antecedent and consequent have no common factors other than 1. Consider the previous example. We have started with 35 is to 50. For this, we have to find the HCF. We know the process to find the HCF. Using the long division method, if we do this, now 7 and 3 don't have any common factor, so we leave it here. The 5 is the HCF. Now divide this ratio with 5, both the antecedent and consequent, we will get 7 is to 3. Now this 7 and 3 both are prime numbers, which means the common factor, highest common factor is 1. This 7 is to 3 will be the simplest form for 35 is to 15. In this way, we can find the simplest forms of any ratio. We'll take another example. Consider 12 is to 4. Now we'll do the HCF for these two numbers. 2, 6, 2, 2, 3, 1. We'll stop here. So HCF would be product of these two numbers, 2 into 2, 4. Now divide this particular ratio with 4. 12 upon 4 is to 4 upon 4. 12 divided by 4 is 3 is to 4 divided by 4 is 1. So the simplest form for 12 is to 4 is 3 is to 1. In this way, we can find the simplest forms. Now we'll practice few ratios. Consider this. The length of rectangle is double of its breadth. How to write ratio for this? We'll do length of rectangle is to breadth of rectangle is equal to double. Double means 2 times. So length is 2 times breadth. Another example, for cooking rice, we need 1 cup of rice requires 2 cups of water. So how to write this? Rice is to water equal to rice is 1 cup is to water is 2 cups. Rice is to water is equal to 1:2. Now let us consider a few more problems. Say we have 150:400 and we need to find the simplest form for this. To do that, the first step is to find the HCFs 150 and 400. So we can start with fifth table as both are ending with 0. Again fifth table. Now we'll do with second table. We don't have any more common factors, so we'll take product of these numbers. 5 into 5 into 2 is 50. We have to divide both antecedent and consequent with this highest common factor. Divide by 50. This would give 3:8 as answer. So for this particular thing, 3:8 is the simplest form. To find the equivalent ratios, consider 14:21 equal to, we don't know the value here, is to 3. For this, compare the consequence. Here it is 21 and in the second case it is 3. When it got decreased, the value got decreased, which means the first value was divided by a certain number to obtain 3. Or you can do 21 divided by 3 and that gives 7. Which shows that here we have done 1 divided by 7 to get 3. We'll divide the antecedent also with 7 and that gives the value 2 here. 14:21 equivalent is 2:3. Consider another number. Say if we have the same ratio, 14:21 is equal to 6 to some value. Again the value antecedents are present in both the sides. The value has got decreased. The case which 14 divided by 6 we have to take, that is 7 by 3. Means 14 was divided by 7 by 3 to get 6. Here we will take the reciprocal and do this. 2 times 2 into 3 is 6. That's what we have written here. The same thing we will do here on consequent as well. We'll divide this with, take the reciprocal. This gives 3. 3 into 3 is 9. So the equivalent for 14:21 is 6:9. Let us consider 5:12 and 3:8. While comparing these two ratios, first we have to see whether these ratios are there in simplest form or not. 5 and 12, 5 is a prime number, so the highest common factors for these two numbers would be 1. 3:8, 3 is a prime number, so the highest common factor here would be 1. So this particular ratio is also in its simplest form. After getting the simplest form of the ratios, we have to find the LCM of consequence. That is 12 and 8 are consequence here. To find the LCM, again 2 times 3, 2. 3 and 2 are prime numbers. So to find the LCM, we have to multiply all these numbers. That is 2 into 2 into 3 into 2, which is nothing but 24. Now, divide the first consequent, that is 12 in this case. 24 LCM divided by first consequent is 12, that gives 2. So the first ratio has to be multiplied by 2. This 5 into 2 is to 12 into 2. 5 into 2 is 10 is to 24. And now we'll take the LCM and divide this with consequent of second ratio. For the second ratio it is 8. 24 divided by 8 is 3. So the second ratio we have to multiply it with 3. 3 into 3 is to 8 into 3, that is 9 is to 24. Now the consequents are same. We have to compare the antecedents. 10 and 9. 10 is greater than 9. So we'll write greater than symbol here, which means that 5:12 is greater than 3:8. In this way, we can compare the ratios. Let us look into another example. Say we have 7:6 and 24:9. If we take this 7 and 6, 7 is prime number. So this is in its simplest form. 24:9. this particular ratio is not in its simplest form. So we'll take the highest common factor for this particular ratio. So the highest common factor is 3. That is why we will divide this ratio with 3 to get its simplest form. This gives 8:3 as the simplest form. Now we have to compare 7:6 with 8:3. Now we have to take the LCM for 6 and 3. We take the LCM, it would be 2, 1. Multiply these numbers. 3 into 2 into 1 is 6. So the LCM would be equal to 6. Consider the first ratio. The consequent from the first ratio is 6. So LCM divided by the consequent from the first ratio gives 6 by 6, that is 1. Multiplying the ratio with 1 means it's going to be the same. And for the second ratio, we have to do LCM divided by the consequent of that particular ratio. 6 is the LCM divided by consequent for second ratio is 3. 6 divided by 3 is 2. So the second ratio, we have to multiply this with 2. This gives 16:6. Now the comparison would be between 7:6 and 16:6. The consequences are same. We have to compare the antecedents 7 and 16. 16 is greater than 7, so we can write this directly. So for the initial ratios, we can tell that 7:6 is lesser than 24:9.